This is Dr. Mitchell again, and we're going to walk through how to do a 2x2 between subjects ANOVA on JASP. So we have a data set here, and our data set, we've opened it in Excel. And let me walk through what we have, and then we'll walk through the analysis. So remember, with the 2x2 ANOVA, we have at least two independent variables. So for this study, our first independent variable is what we call ASD group, which is simply a marker of autism. And so subjects are either high, medium, or low in this variable, one of three options. And so we have three groups inside that independent variable. Our second independent variable is fall history, and that really is just a marker of did they have a fall or did they not? Did they experience one or not? And so a subject either got a 0 if they didn't have any falls, or they got a 1 if they did. So a 0 or a 1. And then we measured something called center of pressure, which is just a variable measured in centimeters in regards to how much their center of pressure moves while they're standing. And so that is an interval ratio variable and something that we can easily analyze. So we have two independent variables, ASD and fall history. These are all between subjects variables. And center of pressure, which is our dependent variable. Okay, so we're going to go into JASP, and I've already opened our data here in JASP. It looks exactly like what we just saw. And we're going to go to our ANOVA. And again, we're using classical ANOVAs here for our analysis. We're going to go to just a classical regular ANOVA. And very similar to what we did in a one-way ANOVA, we are going to tell JASP what our dependent variable is. Well, in this case, our dependent variable is center of pressure. So we're going to put that in our dependent variable slot. Now it wants to know, what are your fixed factors? Or for this, what are your independent variables? Well, we have two of them. We have the ASD group that you're in, and then we have fall history. And you'll notice that immediately when we do that, a ANOVA table is going to appear here in the right side of the screen. Again, with our sums of squares, our degrees of freedom, mean square, F values, and then most importantly, the p-value. So again, what this is telling us, it's telling us that for our first variable, or our first main effect, which is the ASD group, the p-value is less than 0.05. So there is something significantly different there between groups on that variable. For our fall history, p-value is 0.121. That's greater than 0.05, our alpha level, and so that's not significant. And then the interaction, which is ASD versus fall history, is a p-value of 0.374, which is not significant. Okay, so we have some things that are significant here, some that aren't. Again, very similar to other data that we have done previously. We can do some descriptive statistics over here. That'll give us the mean and standard deviation in each group and the N. We can do some estimates of effect size. Just to let you know, effect size, when we're doing 2x2 ANOVAs, we actually do a partial is squared. That's just pretty standard practice as far as that goes. There are other things we can do. Now, the most important one really is a post-hoc test, because we do have a difference in our ASD group, but again, ANOVAs aren't telling us where that difference is. So we're going to go to our post-hoc test, and because the ASD main effect is the only variable that's significant, that's really the only post-hoc test we need to do. So we're going to throw that into our post-hoc test. We have numerous options here. The default one is a Tukey test, but you can use a Chef or a Bonferroni or other ones. We'll just stick with a Tukey one right there. And as you can see, it gives us those values. And so from this, we can see that, the difference is between high and low and high and medium. The p-value between the low and medium group is not significant. So what we can say is that the entire high autistic group, the ASD group, is significantly different than the entire low group, having nothing to do with fall history. The entire group. The entire high group is significantly different than the entire medium group. That's less than 0.115. So that's helpful in knowing exactly where those differences are. Like other analyses we've done, we can do some descriptive plots if we like. And so let's say we want to know the difference between each of these groups, let's say we throw fall history on the horizontal axis and ASD as separate lines. We can do that, and we can see some of the differences here. Maybe we decide, instead we want to actually make each of the ASDs a separate plot. Then it'll do that for us, and it'll give us some separate plots for each of those. So there's a lot of different things we can do with our plots. Again, we can do error bars as well. We've talked about all this previously in other videos. And so we have a lot of different things we can do here that we've done similarly in other ANOVAs. So hope that helps as far as doing this, and hope this lets you do the analysis you're going to do. We look forward to seeing you in the next video.